Hello, welcome to Econometrics Melody. In this video, we will be discussing about the covariance. First of all, the general notation. Then after, we will talk about its vector counterpart. So the covariance of x, y, this is nothing but summation of x minus x bar and y minus y bar and its average. So let us, for the sample, it is n minus 1. We divide it by n minus 1. And if we know this numerator part, we can always divide it n minus 1. That is why we'll focus on the expression on the numerator part. So it is x minus x bar into y minus y bar, and let us play around with it. This is summation, and let us multiply it x y, and then let me write it xy minus x y bar minus x bar y plus x bar y bar. This is the general notation, and now let us operate it with the summation. So we get a summation xy minus summation x y bar minus summation x bar y plus summation x bar y bar. So this is summation xy minus y bar is constant, and therefore we write it as summation in this form. Again, x bar, it is constant, summation y plus this, both of them are constant, and if we add it n number of times, we get n x bar y bar. This is very simple. And again, let us write it as summation xy minus y bar, and then summation x, the total of x, it can be found by using number of the observation and by taking the mean of that observation. It is again very simple. Minus, let us apply the same rule to this as well. So the total of y can be found by the total number into their mean. Otherwise, x bar is equals to summation x divided by n. Therefore, the total of x, summation x, is equals to n x bar. Similarly, summation y must be equals to n y bar. This is what we have done over here. Summation x is equals to n x bar. So summation x bar is equals to n x bar, and summation y is equals to n y bar. This is very simple, and plus n x bar y bar. And if we order them properly, they are the same, so we can cancel one of them. So we are left with summation xy minus n x bar and then y bar. So this is what we have derived. Summation of x minus x bar and y minus y bar is equals to this expression. And this is helpful. This is a very helpful relation. And if we know it, we can always divide it by n minus 1. So we know that the deviation from mean matrix M0 is equals to I minus I transpose I, and where I is equals to the column vector of 1s. So we know this relationship, and where I is the identity matrix with main diagonal element is 1, other is 0, off diagonal elements is 0. So covariance of xy, so the deviation from mean x minus x bar, in vector notation it can be written as m0x, and the deviation from y, it can be written as m0y. We know this. Now to calculate summation of the equivalent of x minus x bar into y minus y bar, we can calculate using this relationship. So m0x, this entire term, this is of order n into 1, and this is also of order n into 1. The entire term is of order n into 1, and we are going to get x minus x bar from this expression and y minus y bar from this expression. And to take the summation of these two terms, what we do, actually, we write the transpose of the first n into 1, and the second we take it the way it is, n into 1. So let us, then after, if we take the dot product, or if we multiply them, then we get this, the result of summation. So here we have x, and here we have y. So we get this product of the deviation of x and y from mean. Now let us write this m0x transpose and then m0y. So the first one is in transpose form, the second one is in its original form. Now here it is A into B transpose. So in matrix, when we encounter this kind of situation, A into B transpose is B transpose into A transpose. And let us use that formula over here, and we get A into B transpose into A transpose, and this is the way it is. And we know that the deviation from mean this matrix, this is an idempotent matrix where the transpose of it is equals to itself, and when we multiply it with itself, the result is itself. So when we multiply with them together, they give the original matrix M0. So we are left with x dash M0y, and it is x transpose, and M0 is I minus I transpose I, and then y. Now let us operate them together. It is x transpose y, x and y are the vector, minus we get it is x transpose I transpose y divided by I transpose I. Now we need to see some of the important property over here. So age I transpose x, this is equals to summation of x. Similarly, is both I and x, they are n into 1 vector. Both I and x, they are n into 1 vector. So I transpose x is equal to x transpose I. There's no difference at all. Similarly, we have summation of y is equals to I transpose y, or we can write it as y transpose I. There's not any difference. And we know that the average of x is equals to I transpose x divided by I transpose I. Similarly, we can write it as x transpose I divided by I transpose I. Now let us use the same property over here, and let me multiply this is x transpose y minus, let me multiply and divide both this by I transpose I into x transpose I transpose y, and then divided by I transpose I. So this is equals to x transpose y in its original form minus and I transpose y divided by I transpose I. This is going to give us the y bar. Let me write it first. So we are done with this. And here x transpose I divided by I transpose I. This is going to give us x transpose, x, the mean of x or x bar. And we are left with I transpose I. This I transpose I is equals to n. So ultimately we got this the same result. Therefore, this is equal to, in matrix notation as well, so the vector x transpose y, vector x transpose y minus, we get it n x bar y bar. So this is in vector notation. And in general notation, what general notation, we got it a summation of xy minus n x bar y bar. Now once we know this, we can always divide it by n minus 1 to get the covariance of xy. And same is the case with the general notation. We can divide this entire term by n minus 1 and we can get the covariance of xy. So we know that m0, this is equals to the matrix responsible for giving us the deviation from mean. So if x is a vector, then if we apply m0x, then we are going to get the deviation from the mean. So if we write x transpose m0x, this is, and if we divide it by n minus 1, we are going to get the variance of x. Similarly, if we write x transpose m0 and then vector y divided by n minus 1, we are going to get the covariance of x and y. So this is as simple as anything. But if we have the matrix x, meaning thereby it contains the vectors of the variables, so x1, x2, x3, x4, and so on, and we have n number of observations, then this is of order n into k, otherwise n into 4. So in this case, if we write x transpose m0 x, and if we divide it by n minus 1, meaning thereby I transpose I minus 1, then we are going to get the variance and covariance matrix. So let me write it x1, x2, x3, and x4, and here also x1, x2, x3, and x4. This the main diagonal. This main diagonal. This is going to give us the respective variance for x1. So let me write it as sigma 1 square, sigma 2 square, meaning by variance of x2, sigma 3 square, variance of x3, and sigma 4 square and variance of x4. And this is x2 sigma 2 1 square. So this will give us the covariance of x1 and x2. And this is sigma 3 1 square and sigma 4 1 square. Here it is sigma 2, here it is sigma 3 and then 2, sigma square, here it is 4 and 2, here it is sigma 3 3 over here, and here it is sigma 4 3 and sigma 4 4 and so on. So these are the covariance matrix and we can interpret them. So this is equals to the covariance of x2 and x1. This is the covariance of x1 and x3 and so on. So this is it for this tutorial. Thank you very much. Thank you very much for your time. Econometrics Mallory.